Well, welcome. My name is Steve Hartenstein. I'm from the Idaho National Laboratory. I'm representing Trevor Cook from the Office of Nuclear Energy, Office of Science and Technology Innovation. For the last 2 years, you've seen Trevor in front of you to talk about nuclear energy, cybersecurity, research, and development. He's unable to make it today, so I will be standing in. I serve as one of his strategic advisors for both developing the components of a R&D program and also as a technical advisor based on the proposals or the awards that we take a look at, review. I have a counterpart at Sandia National Laboratories. He's Mitch McCrory. So both he and I offer advice and guidance as to how this component of the program moves forward. So I'm going to start off with a list of what I'll call a group of very good information and a group of potential noise in the world of nuclear energy cybersecurity. Some of these documents or activities that I put in front of you contain information that describes a large-scale, significant amount of problems or concerns tied to cybersecurity inside nuclear energy facilities and components and systems. Some of them detail potential government action or legislative action that will drive needs. What I ask you to do as you're considering concepts for research is to go through some reports or activities like this to get a good concept of what is relevant and what is not relevant relative to a science research program tied to nuclear energy cyber. A couple of examples I'd like to emphasize is you can look at some of the after reports on the Ukrainian power grid attack, and you'll see components in there that address what I'll call information technology cybersecurity, and you'll see components in there that talk about control systems or operational technology cybersecurity. A science program in the Office of Nuclear Energy tied to this is going to be focused more on the cybersecurity that's associated with what allows the plant to operate safely and effectively, that helps industry move forward to keep their plants operational and sustainable as they move forward. The presidential policy document describes more along the lines about how the nation will respond should somebody find a cyber event. This slide is to describe currently what industry does as part of meeting compliance obligations and regulatory obligations with the NRC. They generally walk through these steps, put together cybersecurity response, and then develop solutions and approaches in order for the plant to function and meet the licensing requirements. As part of our cyber R&D program, we're not highly interested in helping industry come into compliance. We're more interested in coming up with the tools and the science base that allow them to develop approaches to move forward towards compliance and licensing. Over the long term, with the sustainable cyber R&D nuclear program, the Office of Nuclear Energy is going to have several objectives tied to that program. One, we're going to want to reduce vulnerabilities. But that reduction in vulnerabilities will be over the long term of the future of operational power plants and nuclear facilities. We're going to want to mitigate the consequences of a bad event. If an event should happen, how can we demonstrate that bad consequences won't happen? And those bad consequences can't happen because we've either engineered barriers into the process that will prevent that, or we've engineered designs into the system that just eliminate most of the vulnerabilities right up front. We want to make cybersecurity cost effective for the industry. We also want to make sure that the research that we do in here provides a pathway or an avenue for industry and the researchers to come together and say we're working on the right problem for the right reasons. And whatever that results of our research are, they will be deployable sometime in the future to help address the cybersecurity concerns. The R&D program into the future is going to have 3 areas of primary interest from research. We're going to look at ways to manage the risk. Can we develop architectures? Can we look at the supply chain to eliminate, like I said earlier, most of the threats or the vulnerabilities that are inherent to a lot of the current systems we're currently using? Can we develop the modeling and simulation tools that allow somebody to get an answer very quickly to whether something that I use is going to cause benefit or allow things to move forward better, or whether something that we're worried about is actually going to cause a realistic issue. And then we're also interested in coming up with the methodologies, the approaches, and the scientific base to be able to share information with operators, plants, facilities, designers, to understand how cybersecurity can be built into a system to avoid, again, most of those threats and vulnerabilities. With that in mind, the proposal call, which was a very short paragraph, we're interested in, we want solutions, we want proposals that allow us to be able to say we can enable the light water reactors to continue to operate and future designs to continue to operate. We're interested in ideas that would allow SMRs to be licensed, but to come online with some component of cybersecurity built into them, or even looking at advanced reactor designs and say, here's an avenue for understanding and being somewhat confident that cybersecurity is built into those designs. Overall, the program is not as interested in solving a cybersecurity problem today as it is in building the science base for why cybersecurity should be done and how it should be done in the future. Things such as a sustainable architecture that is more resistant or more immune to a cyber attack versus trying to solve a current problem of a current system today. I think that covers the overall approach to the concept. I can take questions now.
How many pre-proposals were there last year in this area?
Am I allowed to answer that question? For the university calls, there were over 10. Less than 15, but over 10.
How many awards are expected in the area?
Am I allowed to answer that question? So in the first year we awarded 2 proposals. Last year we awarded 1. We'll be in that ballpark again next year.
Does the project have to involve the design in LWR, SMR, and other reactors?
No. I think I could add to that question in that the overall program, when it's implemented, we'll be looking at cradle to grave across the whole nuclear energy fuel cycle. So it could be a spent fuel facility, it could be transportation, it could be enrichment facility, or so on. Or even a university reactor can be thrown in there.